All right. So we have covered a lot of information in the last like week. So what questions do we have on like the second half of this chapter? Because we have a whole bunch of stuff we don't do. So either homework questions or just like general questions or whatever we need. Or we want to just practice more things. Because we've done all the things. We've covered everything. But I know we went through everything kind of fast. Yes, dear. That's it. The Descartes rule of signs?
Yeah.
Yeah, let's grab away Descartes rule of signs. Let me grab one real quick. Just so we can practice it. So that's going to be in section 4.3. So that's I'm totally cool, totally fine. So we're going to do in section 4.3. I'll do number. Let's see. Which one do you want to do? Let's do number 39. I know it wasn't one that was assigned, but that's where I'm getting this problem from. We're going to do a Descartes rule of sign. For x to the 5th plus 4x to the 4th plus 3x cubed minus 4x plus 2 equals 0. And we're just doing our Descartes rule of sign on here. We're not trying to find all roots. We're not going to make our list of all possibles. We're just going to do Descartes. So when we're looking at our Descartes, in order to figure out how many possible positive roots we're going to have. So this just tells us about positives, is we look for how many times the sign changes. So this whole polynomial here, we started out, we got positive and then positive and then positive. Sweet, no changing there. Whoop, switch to be negative here. So that's one sign change. So this was positive all the way until we got to here. So that's one. Then we have our minus sign, and it switches to be a plus again. So it went back to positive. So we have 2 times that it changed sign here. So that means we have as many as 2 positive real roots. We don't have to have 2 positive real roots, though, because we might have some imaginary root somewhere. We always are going to count down by even numbers. So we could have 2 positive roots. Or I could have 0. It's always going to be counting down by 2s. So for my positive roots, or my positive real rational roots, I could have 2 of them, or I could have 0 of them. That's what we get from our polynomial right here. To figure out about our negative roots, we have to do an in-between step. Because to figure out about our negative roots, I need to do a substitution. I'm going to substitute in my minus x. I need to know what's happening at the opposite of x. So when we substitute in a minus x, which I'm just changing my color a smidge, what I mean is we're going to take our minus x to the 5th plus 4 times minus x to the 4th plus 3 times minus x cubed minus 4 times minus x plus 2. So we're substituting minus x in as a kind of in-between step. As we simplify these, anything that has an even degree, the sign's not going to change. Because if I have minus x as a quantity squared, minus x times minus x, the negative signs cancel out. If we have an odd degree term, then it will have the sign change. So this polynomial is going to simplify down for our minus x version as minus x to the 5th plus 4x to the 4th minus 3x cubed plus 4x plus 2. So anything within even degrees, sign did not change. My plus x or plus 4x to the fourth, still plus 4x to the fourth. Anything with an odd degree did change in sign. So my x to the fifth became negative x to the fifth. My 3x cubed became negative 3x cubed. And now we count these sign changes for how many negative rational roots we could have. So again, we're just going to kind of figure out where we change. So we started negative and it turns positive. So from a minus to a plus, there's one change. Then we go from a plus to a minus, that's 2. Whew, so it's got bunches. Then we go from minus to a plus again, that's 3. And then we just have a plus till the end. So this one has 3 sign changes. So I could have up to 3 negative roots. What's my other option? 0. Not 0. 1. We count down by 2's. So 2 or 0, 3 or 1. So it's always going to be skipping 1. Because imaginary roots cannot come as singles. I cannot just have one root of 1 plus I. If 1 plus I is a root, so is 1 minus I. If 3i is a root, so is negative 3i. If 5i is a root, so is negative 5i. They always come in pairs. Every single time. So I'm never just going to have one imaginary root. That is why we're always going to count down by 2. So when we're making our kind of list of options, we're going to include all of that information. So we need to include how many positive roots we're going to have, how many negative roots we're going to have, and how many non-real or imaginary we're going to have to get to our total. What total number of roots are we going to have? 5. It's our degree. Every time we have a degree 5. So no matter what, it needs to total up to be 5. This one up real quick with a. So I might have 2 positive roots, and I might have 3 negative roots. If that's the case, how many imaginary roots am I going to have? 0, because I already have my 5 total roots. But maybe I have 2 positive roots, and I only have 1 negative root. How many imaginary roots would I have then? 2. We would need to have 2 imaginary roots. Oh, those are all different widths. I don't like that. There we go. So maybe I don't have 2 positive roots because I've used all my options there. Maybe I have 0 positive real roots. I could then have my 3 negative roots. How many imaginary roots would we have? 2. Okay, well, I've got one more option because maybe I have 0 positive real roots. And maybe I only have 1 negative real root. How many imaginary roots would we have then? 4. So these are the number of options we have for the way that our roots could be kind of arranged. And that's what Descartes tells us. So we're looking at our sign changes, trying to figure out what our options are. So if we were trying to find all of our possible roots, it might make sense to start with my negative numbers because I will have a negative root somewhere. It may or may not be a rational root, so it still might be difficult to find, but I'm going to have a negative root somewhere. I might not have a positive root. I might have 2, but I might not have any. But all in all, it's going to add up to our power level of 5. Good question. I like that one. What else do we have questions about? Yeah. Why don't we do one of the find all of our roots kind of things? Because those ones are long and kind of annoying and they cover a whole lot of stuff. So I'm going to look at one of the ones from 4.4 because we can do the Descartes with that. And I'll grab one of the ones from the homework on 4.4. So between 15 and 30. Let's look at section 4.4. We'll do number 22. It's one of the ones from the homework. This is find all of our roots. And we're going to do a Descartes while we do it. So this was one we did in the homework. It was the 12x cubed plus 8x squared minus 3x minus 2 equals 0. And we are asked to find all of our roots. So a lot of times when we have these find all roots, we start by doing Descartes. It gives us kind of an action plan. It's not something that's necessarily like required. We don't necessarily have to. Sometimes we're going to ask you to do it on them. But it's a way to kind of give us an idea of where to start. We'll write our whole thing out for our total because I can always make this page bigger. So we want to know the number of options we've got for all of these pieces. So if we look at this polynomial here, my 12x cubed plus 8x squared minus 3x minus 2. How many sign changes do we have in it right here? 1. So we know that there is going to be one positive real root. There's no other option. It might, I was going to say, we have one positive. It might not be a rational root. It might be something like square root of 3. That would still be a positive root. Unlikely, but it's possible. But we have a positive root, for sure. To figure out if we have a negative root, that's when we're going to substitute in that minus x. And if we do this in a couple of steps, that's totally okay. I'm going to write it a little bit small. So we're going to have our 12 with our minus x cubed plus 8 with our minus x squared minus 3 times our minus x minus 2. And when we simplify that, we're going to have our minus 12x cubed plus 8x squared plus 3x minus 2. So how many sign changes do we have in that version? 2. Because we started negative and we switched to positive, positive to negative. So this means we have 2 sign changes. So we might have 2 negative roots, or what's our other option? 0. Always count down by even numbers. So I might have 2 negative roots. I might have 0 negative roots. If I have 2 negative roots, how many imaginary roots are we going to have? 0, because we need to get to our total of 3. If I have 0 negative roots, how many imaginary roots are we going to have? 2. So if we find 1 negative root, we know we're going to have another one, because I can't have 1. It's not enough. I either have 2 or I have none. No in between. When we're looking at our finding all possible roots, we're only using this equation. Do not use your minus x equation. That is only used for Descartes. So use our original polynomial. I had at least a couple of times on homework that people wound up accidentally using their minus x, f of minus x. So just be really, really careful. So then let's practice our all possible roots, making our list of all possible options that we could have. So I'm just going to block this off. So here's Descartes. And then our all possibles. That's where we do our factors of our constant and our factors of our leading coefficient. So our constant here is that 2. So factors of 2 are going to be just 1 and 2. Our leading coefficient is a little bit messier this time. That's our Q. Because our Q has a bunch of factors, our leading coefficient. Because 12 is one of those things that just has a gabillion. So our Q has factors of 1, 2, 3, 4, 6, and 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. You don't have to put them in numerical order. If you do, that's totally fine, but it is also fine to just write them out like this, or do 1 and 12, 2 and 6, 3 and 4, and write them out in that pair. When we are setting up our list of all possible options, setting them up as fractions and then simplifying sometimes helps, and making your full list to then simplify. If you can simplify as you go, great. If you can't, that's okay. So I'm going to do the full list, because we're going to have P over Q. I'm going to have 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, and 1 over 12. Then I do the same thing with my 2's. We're going to have 2 over 1, and 2 over 2, and 2 over 3, 2 over 4, 2 over 6, and 2 over 12. A lot of these are double covered right here. I have more pieces written than we're going to need to test. Because when we come through to simplify this, which will make this a lot easier to work with, this is when I'm going to work in my plus or minuses. So we're going to have plus or minus 1. 1 over 1 is 1. We're going to have our plus or minus 1/2. Plus or minus 1/3. Our 1/4, 1/6, and 1/12 still are hanging out. It's in our 2's that we're really going to get some simplification happening here. Because we're going to have our plus or minus 2. 2 over 2 simplifies down to be 1. We've already got that. Our 2/3 we do still need to have. 2/4, so that's 1/2. I already have that in my list, so I don't got to worry about that. 2/6, that is 1/3. I already got that. 2/12 is 1/6. I already have that. So this is my full list of all possible options for us to test. So what we do from here is we're going to go through and we're going to just kind of do a guess and check situation. To get to where we can find a solution, we need to find something that works. So this is our all possible options list, and we've got to plug things in, substitute in pieces, try and find somebody that's going to divide up. And so we can type them in the calculator. You can brute force them. You can do this with synthetic substitution or synthetic division, trying to find one of these that gives us an answer at 0. So we're going to take our f of x and we are going to substitute in pieces. F of x into this one up here. I'm going to substitute in for our 12x cubed plus our 8x squared minus 3x minus 2. And we can test a whole bunch of stuff. We can do 1, -1, 2, -2. We know for sure there's going to be a positive root somewhere. So if you want to focus on positives, that's totally valid. We also know if I find one negative root, I'm going to find another one. But we just kind of do a guess and check at this point. And we can kind of cross things out as we go through it. If I do my f of 1, and I substitute 1 in, and I type it into my calculator, we should get 15, so we know it's not going to be 1. And if I do f of negative 1, I get negative 3. So I know it's not going to be 1 or negative 1. And I can just kind of use this master list to cross things out and test things. If we're doing this on something like a quiz or a test and you're crossing things out, just don't cross like that so I can still see what it says. An X is fine, just don't like scribble it out or erase it. Did anyone find a root that does work? 1/2. So if we put in f of 1/2 or 0.5, if you do it in the calculator, either way is totally fine. We do get 0. So a root of positive 1/2 works. So that means this is a root. Once we find one that works, we're going to be able to find the rest of them. Because if I can find one that works, what we're going to do is I'm going to take my function and I'm going to divide that root out. So since we know a root already, I'm going to use synthetic division because I know I have a root at 1/2, which means I can set up my synthetic division like this, taking my coefficients. Grab a different color. So my coefficients being my 12x cubed, my 8x squared, minus 3x minus 2. And using our synthetic division. Our first term drops just like normal. 12 times 1/2 gives us a 6. And then we're going to add. 8 plus 6 gives us a 14. 14 times 1/2 gives us a 7. Negative 3 plus 7 gives us a 4. 4 times 1/2 gives us a 2. And when we add those together, we get our 0, which is what we expected when we multiply this out. So this is giving us a quadratic of numbers. We started with a cubic, it was an x to the third. This is going to be our constant. This is an x. This is our x squared. We're given a function that looks like this, or a quadratic piece. So we're going to have a 12x squared plus 14x plus 4. And if I still want to find more roots, because we want to find all of our roots, I can find them from that. We can factor that. What do we need to do first when we try and factor this guy? I'll change the view. I'm just trying to make it so we can see it. What do we need to do first to factor this? Yeah, we've got a greatest common factor here. We're not just going to start with our a times c. We got to check for a greatest common factor first, because what are these all divisible by? 2. So this is the same thing as 2 times our 6x squared plus 7x plus 2. That's going to be a lot easier to factor and much less prone to mistake. So always double check for a GCF. And we can use this to find the rest of our roots. That's when we're going to do our a times c at the top, b at the bottom. 6 times 2 gives us a 12. B is a 7. We need a pair of numbers that multiplies to make 12 and adds to make 7. 3 and 4. Be careful with our factoring. Our roots are not 3 and 4. Use a tool, box, split the middle, bottoms up, whatever tool we use. When we factor this guy, we should get 2x plus 1 and 3x plus 2. This is how we can find our remaining roots, solutions, zeros. What is the root for this piece? Negative 1/2. What is the root for this piece? Negative 2/3. And if we look at our list of options, plus and minus 1/2 was an option, and 2/3 was an option. They're still in the list. They were options we had there. So our factors, our roots are positive 1/2, negative 1/2, and negative 2/3. So that covered a whole lot of pieces there. I'm trying to make it so we can see the whole thing. Questions on any of these pieces, because there's a whole lot of. Okay. What else do you want to look at? Are you feeling okay? Because we have a lot of stuff. If you want to have the rest of the time to like work on homework, work on the review, that kind of stuff, now's a great time to do so. Any of us that are missing like quizzes, this would be a good time to do that. I'm going to pass back what I have for you guys. If you guys have more questions that pop up, let me know. I'm happy to work through some. I'm going to put these up here. This is the numbers, just because I know, whoop, not the button I'm in. There we go. This is not additional, this is just the numbers, just because I know we've been a little rushed on time at the end lately. So I'm going to pass back the things I have for you. So we do have a chapter test coming up on Friday, so make sure we're working on that. If you need a copy of the review, I've got them right here. Yes, dear. Absolutely. So, review for the chapter test are right there.